So let's talk about PCHEM. What is it? Well, it's not really this. Okay, this is from Ant-Man and Wasp, the quantum realm. All right, so it's a real trippy place. But we will talk about this quantum realm a lot. That is the interaction of light and matter. Okay, so light comes in, interacts with subatomic particles and so on, and light is really our tool for understanding what's going on in that atomic scale. There's really no other probe that we have. We do have atomic force microscopy now that can actually tap the surface. You can take a little silicon chip and like dissolve it slowly, and it'll get an atomically sharp tip, so like one atom on the end, and you can get that atom close to the surface and measure the electronic current. And when it gets close to the surface, you'll start to see a little current jump as electrons tunnel through the gap. And so you don't have to actually touch the surface, but you get close enough to measure its roughness. And since you have an atomically sharp tip, you can measure single atoms. And so we actually, in the 70s or whatever, IBM pushed around xenon atoms on an atomically smooth nickel surface and spelled out IBM. So you can go see that on the web. And so that's our we've seen atoms. Okay, so definitely nature is particulate, but then it behaves like waves too. So particles should be able to have any energy, right? You put a ball on a ramp, it can go anywhere on that ramp, it can have any energy. And so that would be what we would call classical physics. And so in this first part of the course, we're going to contrast classical physics and the failures of classical physics with quantum physics. And quantum physics would be like stairs. So if you have a ball on the stairs, you can put it on discrete stairs, but you can't have it in between the stairs. And so why would nature be quantized? How can we figure that out? Well, waves are quantized. If you think of a guitar string, you can strum it and it has a particular tone. There's a particular waveform. If you touch it halfway and pluck it again, you get a node in the middle and it goes up an octave. Okay? And so you can't get a note between the octave and the fundamental. The string won't vibrate that way. It will either vibrate the whole string or half the string or a third of the string and so on. And so you set up these standing waves. The standing waves were proposed by de Broglie, and we'll talk about that later. So this idea that nature is wave-like in properties, that was the birth of quantum mechanics in the quantum realm. Quantum just means like a small packet. Okay, that's all that word means. So discrete units, so like stairs. So whenever you think of quantum, just think of stairs. So nature it's really strange. Why would nature have discrete stairs of energy? It's because nature is behaving like a wave. And so light's behaving like a wave, all of nature is behaving like a wave, and so we're talking in this whole course about how these waves interact. And so it's really a wave mechanics class.